Okay, so it's time for some more daily math puzzles. I'm going to start by giving you the answer to the last puzzle I posed, and then I've got a new pretty interesting puzzle for you. So the last puzzle I posed was to show that for integer, well, it was a question really. The question was for integers a and b, when is a divided by b plus b divided by a an integer, and justify your answer. So if you want more time, pause the video now, because here comes the solution. Okay, I thought I'd get it right today. Well, this is the question then. For integers a and b, when is this an integer? So here's the argument. We suppose, without loss of generality, that a and b are relatively prime. That means they have no prime factors in common. We can suppose this because in these expressions only a divided by b and b divided by a appear. So if these numbers did have prime factors in common, like they're both multiples of 2 for example, then those common factors would get cancelled here anyway. So we can suppose that a and b are relatively prime, and we can suppose that a is bigger than b without loss of generality. So now let's suppose that this quantity is an integer. We'll call that integer k. So if we then take this, we can rearrange this expression here to give us that a squared plus b squared equals abk. Now let's rewrite this in terms of b. So we get b squared equals a times bk take away a. So what this means then is, since this is an integer, we must have that a divides b squared. But that's just not possible unless we have that a is plus or minus b, because a and b are relatively prime. So basically this is our condition, that a is equal to b or that a is equal to minus b. They're the sort of if and only if condition for this quantity to be an integer. So I hope you enjoyed that one. Okay, so here's the next puzzle. We have a circle which has radius 15 and we have a circle which has radius 20. These two circles intersect at right angles, and the problem is to work out the difference of areas of the non-overlapping regions. So there's going to be, of course, a region where these two circles overlap, and then there's a non-overlapping green region here belonging to the big circle. Let's say that has area A, and then there's a non-overlapping blue region here belonging to the smaller circle. Let's say that has an area B. We want to determine what A minus B is. So that's the problem. And see how quickly you can do it. It's a pretty fun one. There's a very fast way to do it if you think about it in the right way. So good luck with that.